Nanoelektronika. Šeit ir mani izmantotie informācijas avoti. Kas ir nanoelektronika? Nanoelektronika ir nanotehnoloģija izmantošana elektriskajos komponentos. Šeit ir video, kas paskato šo tematu labāk.
In 1946, the American public was introduced to the world's first general-purpose computer, named ENIAC.
Giant electronic brain is starting cogitating at the University of Pennsylvania.
ENIAC was a gigantic leap forward for computing technology, but at nearly the size of a classroom, it was not very user-friendly. Today's computers, tablets, and smartphones are not only millions of times more powerful than ENIAC, but small enough to fit in our pockets. Not only are electronics smaller, but the microchips, the computing devices that make computers work, are now the size of tiny breadcrumbs and can fit inside everything from watches to pens to greeting cards. How have computers been able to get so small, fast, and have greater functionality? The answer is nanotechnology, the study of the manipulation of matter on an atomic, molecular, and supramolecular scale, where 1 nanometer is equal to 1/1000th of a meter.
Everything in information technology is really based on nanoscale devices.
Tom Tice is the director of the Nanoelectronics Research Initiative at the Semiconductor Research Corporation and a researcher at IBM. The initiative, funded in part by the National Science Foundation, studies one of the most popular applications of nanoelectronics, microchips, or integrated circuits, and how they could be made even smaller, while at the same time increasing their efficiency.
The smaller we make these things, the more of them we can make at the same time. They also get cheaper. And that's why now you have a smartphone that has the processing power of the biggest supercomputer from not so many years ago.
Microchips are composed of transistors, which are made of materials called semiconductors. Today, more than 60% of transistors built by U.S. companies make use of nanotechnology. As an electric signal flows through them, the transistors switch on or off, represented by the numbers 0 and 1, to digitally transmit, process, and compute information.
The image that you see on your phone screen is really represented inside the phone as zeros and ones, which correspond to on and off states of these many, many millions and billions of switches.
The first computers built after the ENIAC contained only about 800 transistors. The microchips of today typically house anywhere from 2 to 6 billion transistors, with wires that are only a dozen nanometers in width, a fraction of the width of a human hair.
We need switches to make computers, and the smaller we can make those switches, the faster they tend to be, the more information we can process.
As transistors and microchips continue to shrink in size, engineers are excited to contemplate what the next step in microchip evolution might be, how small they can go, and what they can be used for. Already, new applications have emerged, from social networking to environmental monitoring and medicine, and even more could come in the future.
Oh, so you could use the foil to charge the batteries?
Yes.
Ana Claudia Arias is an NSF-funded scientist at the University of California, Berkeley. She believes that if microchips were engineered to not only be flexible, but also be able to work inside the human body, it could mean a breakthrough for the future of nanoelectronics.
My research group in Berkeley is looking at how to fabricate flexible devices for several applications, for large area electronics or for wearable medical devices.
Arias and her team are currently in the testing and development stage of designing microchip-based electronic sensors made of flexible, biocompatible materials like gold and other conductive metals. These nanosensors could one day be physically implanted into a patient's body, collecting and transmitting valuable information to the physician.
One of the goals of our research is to have a suite of sensors that allows us to monitor all the vital signs, such as oxygenation levels in the blood, pulse rate, temperature, and possibly changes in blood pressure.
After a short time inside the patient, the nanosensors will be absorbed by the body, much like stitches. Nanotechnology will become more and more integrated into our lives in the future, but today we're already benefiting from this groundbreaking science.
Just about everything that humans are trying to do in science and technology is benefiting from advances in nanoscale science and engineering.
As microchips continue to become smaller, faster, and more powerful, scientists and engineers like Thijs and Arias are continuing to push the boundaries of nanotechnology by making electronics and our bodies work together.
Nanoelektronika statistika Latvija. Apkopojot universitāšu zinātnisko institūtu un centru priekšlikumus, kas nozīmīgākos Latvijas zinātnes sasniegumus teorētiskajā zinātnē, nosaukusi jaunas metodes izstrādāšanu, kvantuma algoritmu izveidi un jauna kvantuma interferences pielietojumu izstrādāšanu nanoelektronikā, ko iztenojuši LU pētnieki Andris Ampainis, Vjačeslavs Kašejevs, Aleksandrs Pelovs, Jānis Timošenko. Viņi arī atrada, ka halkogenītu pārklājumus nanotehnoloģija un nanoelektronika ir iespējams kristalizēt ar elektronu kūļa palīdzību izmantošanai elektronu litografijā. Pieejamo produktu piedāvājumu klāstu, kas izmanto nanoelektronika. Produktu klāsts, kas izmanto nanoelektroniku, ir ļoti plašs. Jūsu telefoni un datori iespējams izmanto nanoelektroniku. Nanoelektroniku klātbūtne mūsu ieredzes vēl vairāk palielināsies, jo nanotehnoloģijas kļūs lētākas. Padomājiet tā. Šie taps vēl stiprāki un lētāki. Bet kāpēc nanoelektronika? Ja nanoelektronika ievērojami palielina robežas tām, ko mēs varam darīt ar tehnoloģiju. Pateicoties nanoelektronikai, mums nākotnē būs telefonu baterijas, kas uzlādējas uz 5 minūtēm un būs uzlādēti ilgāk. Un tad arī kļūs stiprāki par lētāku cenu. Šeit ir manis pašvērtējums. Paldies par uzmanību!